Hi everyone, and welcome to yet another Friday afternoon webinar with NORA. Today it's AI and Ruter that we'll hear more about. Umair here will talk about Ruter. Umair is head of data science, artificial intelligence, and data warehouse at Ruter. Additionally, he is also an assistant professor at OsloMet, where he teaches artificial intelligence. From the startup world, he has also experience. He is a founder of and CTO for bineric.com, which is a data labeling platform for artificial intelligence algorithms. He's also the previous CTO and co-founder of TPO.no. And I should also mention, Umair, on the community side, that you are launching Offentlig AI, which I also have had a great pleasure attending many meetings. So thank you for building up that community as well, Umair. So with that, I think I will just leave the screen for you.
Thank you, Klaus. Thank you for having us. Let's see. Okay, so I'm going to skip the introduction part of myself since Klaus has already covered the introduction. The focus for today's presentation would be artificial intelligence inside Ruter. I'm sure a lot of you already know what kind of organization Ruter is, but I will cover a few parts for those of you who are from abroad and have not heard about us. So Ruter is a transport company, and we provide transport services like bus, trig, train services, and we provide transportation services in Oslo and the Akershus area. And that total number of people we actually transport is around the people who we target is around 1.4 million. And in a country like Norway, whose population is around 5.1 million, it's a huge amount of people we actually transport. And yeah, on a typical day, like before the pandemic, we had around 1 million boardings every day, and we had around 150,000 tickets sold every day as well. And we had a very organic growth since 2008. Everything was fine, passengers were going up, and the focus was more towards collective transport, and things were looking very good. And then all of a sudden, pandemic hit, and we had around 40% reduction in our boardings. I don't have most updated numbers of our situation is, but we still are not back to the pre-pandemic levels. But we hope we'll get there soon. And I mean, everyone hopes we'll be back to that environment. So let's talk about what Ruter's digital services does. So what we do is we have a digital platform inside Ruter. And a Ruter's digital platform is like an ecosystem of different applications. There are many applications which exist in their own environment, and they communicate with other applications by sharing data inside Ruter's digital platform. So it's a huge, one big ecosystem of different applications. And then we have multiple data producers which continuously send in data to our platform. And then we have multiple consumers of that data as well. One of the biggest data sources I would like to talk about is our bus. And when you go inside the bus, there are multiple sensors in the bus. You might not see them, but those sensors are giving us or sending us real-time information. And that information is everything about weight of the bus, the distance it has traveled, how many passengers are standing inside the bus. It even has information about the status of the wiper and also the temperature on the road. And we get this data in real time. And then when this is like key data for us. And then we use this data for various algorithms inside the organization. I mean, we have more data sources, but we'll not cover that information. I just want to talk about this one since this is the most important one we have. So that's the background. Let's jump over to the AI projects inside Ruter. The first project I'm going to talk about, it was customer insights. Now, this was a very huge requirement inside Ruter. Like, Ruter is the customer-facing organization, and like any other customer-facing organization, the need is that you want to gather insights about your consumers. So what we did was, okay, before I say like what we did, I'd like to inform about timeline of events. So, like Ruter has a customer service department, and since we are a consumer-facing company, so our customers always has these. Sometimes they have problems, and they come to Ruter like, we have this problem, and then our customer service department fixes those problems. So the timeline of events is that customer has a problem, they make a complaint, send a complaint to Ruter. The customer service department inside Ruter resolves that issue, and everything is fine. We have a happy customer, and things are back to normal. But sometimes things can go bad. And what happens is that customers have a problem, they send in a complaint. For one reason or the other, the customer services department was unable to resolve that complaint. And the issue becomes bigger, keeps on getting bigger, and we reach a situation where you have a lot of users complaining about the same problem. And what happens is that it comes in the newspaper. It blows over, it comes in the newspaper. It also leads to us getting bad reviews directly from the users. And that's bad, because we are a company which is oftenly eyed, right? The state owns us, and we are answerable to the people of Norway, and of course we are answerable to our owners as well. So when you have that thing blowing over, it's not a situation we want to be in. If you have been following the newspapers inside Norway, you might have seen these kind of news coming up. To be on the other end, to receive all this information, is actually a very bad situation for us. So we were thinking like, how can we stop this from happening? How can we use artificial intelligence to identify any problem before it becomes so big? So that was the goal. And that's where we started looking into our data from customer complaints. And so we had the data from our customer complaints, like all our customers who are sending in complaint. We started we had a look at the project, and we were like, how about we start looking into how angry our customers are? Now, I mean, in AI, it's called sentiment analysis. When users send a complaint to the organization, we already know they're angry with us, but we wanted to see how angry they were. And so we did some clustering on the different segments of complaints, and we got to the graph on the right-hand side, or the image on the right-hand side. And there you see like green being the mild one, and then you have yellow, which is a bit more angry, and then you have red, which is more angry, and then you have the black one, which is extremely angry people. And we took that data, and when we knew what kind of complaints we were talking about, we then mapped it on, we just put it on the map. So then exactly we knew in which area people were most angry, and this made us identify those areas where there was a need to actually focus more on. That was very useful for us. We then wanted to, the second thing we did was opening up the data to everyone in the organization. And this is very important, because when you want to create an organization which is driven by insights, a data-driven organization, and an organization which uses insights to make a decision, you need data to be open to everyone. Now, the problem with existing data was it had a lot of sensitive information. When people write to us, they give their usernames, so they give their full names, they give their phone number information. Some people even share their account number, and some people even tell us about their health issues. And since we have a huge oversight from data till CNA or GDPR, we were actually, there were only a small group of people inside Ruter who had access to this data. And even though I'm an employee at Ruter, I didn't have access to this data. So what we did was we anonymized all that information. So if you take a look at this data, I mean, the original data had all the sensitive information, and we anonymized it, so it didn't have any sensitive information anymore. This was a huge thing for us because after doing this, we were able to open up the data access to everyone inside the organization. We still have this legal thing going on in our legal department, who still thinks that the data is not completely anonymized. And of course, we have to abide by their rules. So we cannot really say that it's fully anonymized. But we think it's anonymized enough that more employees in Ruter can have access to this data. We also did another interesting thing. We used AI to find hidden trends in the data. So what does this mean? If you go to contact.ruter.no, you will see like predefined classification of complaints you can use to send in. If you have problems with the tickets, you can select that. If you have problems with the arrival time, you could select that, and so on. But when we started using AI, and we just use a clustering scheme where you can actually give AI the power to group different classification of complaints together. So for example, in the image in front of you, what you see is different colors are showing what people are talking about. And if people are talking about the same thing, then what clustering does, it groups similar data together. So the orange color over there shows people who are talking about the same kind of problem. Red is one kind of problem, blue is one other kind of problem, and so on and so on. When we gathered our data in this way, we were able to identify 3 new interesting categories, which we had not identified earlier. And that was like a lot of people were talking about congestion there was a lot of congestion inside the bus. Some people talking about that one. Some people were saying that the buses were it was not wheelchair accessible. And a few people were also complaining that talking about problems with music. Now that is that is a subjective thing, because some people said that the bus driver had a bad taste in music, whereas others said like the music was too loud inside the bus. And of course, I mean, by that time, our data was clean, it was transformed. So what we did was we just were like, how about we just visualize it? And that's what we did. So we use a simple reporting tool called Power BI, and then we just pushed all the data in it. And these are just snapshots, screenshots from our reporting tool. But on the right-hand side, you have this map. So if you zoom in, zoom out, the data on the left-hand side also changes and the graph updates. So that was so on this screen, you see like the complaints. So you see, if you zoom in the map, you can zoom in on a specific area, and then you will see like these circles will show how big number of complaints there are. And on the right-hand side, you will see all the complaints coming up as well. We have like hidden all the complaints due to GDPR. This is another kind of screen. So what you do is you can, on the left-hand side, you can search for specific free text. You can write whatever text you want, and then all the complaints will come up. For example, if you want to see if people are complaining about temperature, you can just write temperature as a keyword, and all the complaints will come up. And then you can zoom in, and on the map, you can see where exactly people are talking about. This is more like a sentiment analysis report. So on the left-hand side, you can like select the specific bus, and for that bus, it will also highlight the path where exactly people were happy and people were most angry. And if you click on the red circle or the green circle, below you will see like all the complaints coming up. Like at this specific time, people were happy and they were saying this, or at the specific time they were angry and they were saying that. Another example where you have a different kind of graph, and then on the right-hand side, you see all the routes, and right-hand on the most bottom side, you see all the stop information. So this way we were able to see which stop had the most amount of problems, and then we could focus directly on that stop and then resolve all the issues happening over there. These were like simple dashboards we had, like so in the center, you see like of every gauge, you have a number. So if the value increases for that specific average, we have to look at it. This is really bad. Or if it stays below, then everything is fine, no problem. Another example, and yeah, I mean, another way of looking at the same data, just creating another report on it. Yeah, this is the last screenshot I'm going to show for customer insights. So what we did was like, we wanted to extend it more. Like the data right now is coming from our customer complaint system. But we were like, how about we extend it and include Twitter, social media, Facebook? And if we do this, we'll be able to get a better idea of what our customers, the problems our customers are facing today, and how can we solve those issues. So we have not done that yet. We have not done the full integration with Facebook or Twitter, but we want to do that. Right. So the project one was customer insights, and then we showed the customer insight using a reporting tool. Now, by that time, we had actually processed data, and we were like, how can we use this data more and do something more? And the solution was like, how about we make an AI-based case handler? Now, why did we need it? So what happens is like, if you go to contact.ruter.no and you select, for example, forsinkelse or avvik, that is like delayed or cancellation, and you write a text and you send it in, it comes to our automatic customer services support center, and then one person will start looking into that one, and then we'll follow up on the use case. So let's take drifts avvik, for example. If someone is talking about forsinkelse avvik, then we know that people will be talking about short for sent, short for tidlig, or instill. That means like either it was delayed, it was early, or it was canceled. And it's around almost 7% of our complaints when they come in, they belong to these kind of group of issues. And the thing is, like, if a person is standing on a stop and they send a question to you, and by the time we resolve that question, of course, we are humans, like sometimes it can take us time to resolve, to follow up on a question. So by the time we answer them, the context of the problem is already over. The bus has already come, or they understand from someone else that the bus is canceled, and so on. So we were like, how can we make it faster? How can we make sure that instead of a human answering, how can an AI agent answer it in the most effective way, so we don't have to wait for that long? So what it does two things, like it makes our user happy, and it also reduces the load on our customer services department. So that's what we did. So the first step in that project was, of course, to predict like a human, and we started working with the predictions. So these are examples of the predictions which the algorithm got right. The first is like when it was delayed, and the second is when it was canceled. And the algorithm analyzed the message, and it correctly predicted that it was either canceled or it was delayed. But we also got wrong predictions. And if you take a look at this text, and I'm sorry for people who do not understand, I'm sorry we don't have an English translation for this one. So I apologize in advance. So what I'm just trying to, I'll just give you an idea of what's happening over here. So in this context, in this, the message which came in, the person was angry about 2 or 3 different things. And then if you as a human look at this message, you will understand that the bus was canceled and it wasn't going to be run at all. But what our algorithm understood was that it was probably delayed because there was 2 or 3 different contexts which the person was talking about. So that was also like a exceptional case which we handled, that this is something, if the text is longer than 200 characters, then perhaps it's better if you redirect it to a human instead of the algorithm managing that one. We did the measurement, and our algorithm gave us like 89% correct prediction, which was very good. So we were like, how about, this is a very good prediction score, and this was acceptable for us. And yeah. So I mean, we tested it, and then it came out in 9%. We were like, this is good enough for us. So let's deploy this into production. And we did. So what happened then was, like, this is the same business use case, but now you have this there. So this is in production now. And if you go to contact.ruter.no and you click on Forsinkelsen Avvik, and you send in a question, for example, if you send in that question, this is the kind of reply you would get from us. And we did a test So the question was set at 21:46, and of course the reply came immediately in like 20 seconds. And this was a huge thing for us because it kind of made sure to reduce the time on customer service, and of course also to make sure that the user was also happy. As I say again, like, it's not all the incoming questions which go directly to the case handler, to the AI case handler. Some of them are redirected to us humans as well. Yeah, so both projects were very related. So summary for both. The first one, the customer insights report, is being used by almost 200 people inside the organization. So I mean, this kind of fulfills our needs of making Ruter more data and insights driven. And we did an estimate that the AI agent has actually saved us, or it replaces like a full human person for us. So it has saved us a lot of hours. And the cost for these 2 projects was very good. We completed the project in 3 months. It cost us only 300,000 Norwegian kroner. Everything was in-house developed, and we hired like 4 students to work on this project. And of course, we had 1 team lead from Ruter who was working on it as well. This is an example of a project which was like, which was developed by students. So this means like they didn't have so much experience from before, but they developed it in a very short time frame with the minimal amount of investment, and they gave so much value to the organization that we can't even compare it with any kind of, yeah. I mean, you can buy a lot of things off shelf as well, but this gave us a lot of value. Right. The third project I'm going to talk about is capacity prediction. And this is like trying to predict the number of passengers using AI. And the use case is very interesting because for us, it's very important to know how likely the bus will be full in the next hour, the next day, the next week. And the first use case we had was during Corona time, because what we wanted to show was to our users, like, if you want to, because of COVID, if you want to pre-plan your travel and you don't want to sit in a bus which is already full, we wanted to inform you beforehand that this was already full. And second thing was, like, internally, the operations department in Ruter, they needed this information. They wanted to know how full the bus was. So if they knew in advance, like in the next week, our AI has predicted that the bus will be full on this and that stop, then they can optimize their route planning by sending by not sending more buses at one specific stop, and trying to send all the buses in the other stop. And that kind of helps us because this improves, or this kind of relates to our ESG goal. We want to be we are a sustainable company, and we take pride in a sustainable company. So this kind of improves or focuses more on our ESG goals. Yeah, this is an example of the apps which use the data from that algorithm. Yeah. The other project was personalized journey recommendation using AI. So you've already used our app, and what we wanted to show in our app is that right now it's like you put in a search like from here, from there, and then the app will give you recommendations. But what we also wanted to do is to give you recommendation based on your travel pattern, something you have traveled from before. And that's a tricky area, right? Because that's where personalized information comes in. And our law department is very strict on us when it comes to using personal information. So we have to develop algorithms around those restrictions, around data silciness restrictions, around GDPR restrictions. So the first version of the algorithm we proposed was actually based on a paper, on a research paper. And that algorithm does not uses any server communication at all. So it stays on on your phone, and what it does, it uses your approximate location and suggests the closest point for you. That algorithm does not use any AI, but it's based around the same concept. So that was version 1 of our algorithm. The version 2 of our algorithm, which will use more AI, is currently under developed. And of course, we have to consult our legal department before we can deploy it or use any personal information. So this is something we are currently working on. The fifth project, which uses a considerable amount of AI, is the data quality part. Now, the thing with data quality is that you probably have heard of the terminology garbage in and garbage out. So if you have a lot of bad data coming in, everything fails, right? The reporting fails, your algorithms fail, all kind of web services also fail. So we have the same problem over here. So and every organization which has some kind of production system, somewhere down the line, data will become bad. And it's a problem that every organization goes through. So we had a few sensors in our bus, and we had a few other systems who were sending in. Sometimes, most of the time, they were good data, but sometimes some bad data comes in. So what we did was we used a model called imputation model to clean that data. What that model does is it looks at the historical information, and it tries to find trends in the data, and then it tries to recreate or replace the bad data with the clean data. And that has helped us a lot, because the quality of the data suddenly increased to 97%. And that was good enough that we could actually do our all kind of reports on that data. And we could also use, and I mean, of course, the AI algorithms are very important, because if you have 97% good quality data, your algorithms will also work in a very efficient way. The sixth project we did was using was travel time prediction, and this is similar to capacity prediction, but this predicts the estimated arrival time for the bus. And again, this is very important, because in travel time prediction, what we are also trying to show is that if we can predict at what time the bus will come, we can use that information and we can properly plan our fleet in advance. So estimated time of arrival, capacity prediction, these are all related with each other. And this, by providing these two algorithms, we are aiming to reduce the traffic on the road. We're also aiming to make sure that you don't have an empty bus going on some route. Again, this focuses on our sustainability goals for the company, convenience, and yeah, of course, making our users trust our services more. The estimated time of arrival, the previous one, is not really in production right now. So yeah. So I mean, I think this is probably the last project I'm going to talk about. This is explainable AI. So we have a lot of AI projects going on inside Ruter. And I think our AI environment is pretty mature now. So when you have so many models working, when you have a lot of data which is consumed by AI, you then start thinking about explainable AI. And then you would get questions like, how would you explain the algorithm? How would you explain the data which is coming in? And that's exactly what we did. We built our own system around it. And the system was built on, we wanted to first of all have measurement of how good we wanted to see how good predictions we were making. We also wanted to see how our predictions were evolving over the time. And this is very important because if for some reason your prediction goes way off, then the baseline estimate, then there's a problem. I need to identify why did it go why did it deviate so much? The models as well, we wanted to control various models and see which one given the right prediction. And of course, data is extremely important. So the training data is important. Did anything happen to your data pipelines? Did data pipelines break at any moment? And so we need to have like complete control over that as well. So we build our internal monitoring tool on this. So just have a few snapshots from that one. But the image from the left hand side actually shows you the predicted passenger count and the actual passenger count. And then, I mean, there's helpful information like the actual data all the way on the left, and then you have the line information, and then you have the graph all the way down. So you can actually see at what time. So the green actually shows it was very good prediction, and the red is actually bad predictions. You can see why there was bad prediction. You can drill down all the way down to the stop level information. Then it gives you an overall measurement of how good your predictions were. And you can actually traverse it back in time and see when was it bad, why was it bad, what factors caused it to have like a bad prediction, and so on and so on. Yeah. So I think that's it. That's the presentation from my end. I just want to say what's next after this. So afterwards, what we are planning to do is that we think our AI environment is pretty mature enough. So what we are doing right now is looking at quantum AI. We want to explore, like, okay, right now our algorithms takes X amount of time to compute, or the data engineering part takes like X amount to compute. Can we increase it and make it more efficient by using quantum AI? So that's a project we're going to run this summer, and we have already 2 positions announced on it. So yeah, that was it from my side.
Thank you, Umair, for a very interesting presentation and many excellent case studies and examples of how you apply AI in Ruter. So please, everyone, write your questions now in the Q&A, and I will read them up to you, Umair. So we already have a couple of questions. One from Sabri Rajek. Do you have your own infrastructure for ML at Ruter, or do you use cloud-based on-demand resources?
Yes, so the answer to that one is like, we tried with our own infrastructure. I mean, the first algorithm we were writing during customer complaints, and I mean, when you create one model, it's fine, you have control over it. But as soon as you create the second model and the third model, you realize you need like some tools that can help you out. So we use Amazon SageMaker, which is provided by AWS, and that has actually helped us a lot. There was a talk by Ruter on JavaZone on our machine learning pipelines, and those are actually, it's a very relevant talk, and I would advise you to, if you can access it, take a look at that one.
Excellent. More questions. Is it possible to anonymize data even further and open it for research?
thing is, there are, oh, you mean like data itself, not the tool?
Yeah. And if not, maybe how could one use synthetic data, or yeah, it's an excellent question from Sabri. At least could you anonymize it and open it?
So the thing is, like, the anonymization we have done, there's like a discussion going on inside the organization. So the technical team is very proud of the anonymization work, and they think most of the data is anonymous. But the legal department, who are experienced with GDPR, they don't agree with us. So they are like, it can still be traced back to a customer in this and that way. So they, so I mean, there will always be limitation with the technology and how much you can anonymize it. And the problem is that we, as an orphan company, if there's a case of even one line or one piece of information which is not anonymous and it is found in the data, then it can have huge problems for us. So then it's for Ruter as an organization, we can't really take those kind of risks.
No. I mean, we meet this all the time, of course, that the downside of stepping wrong there is so huge compared to the upside, just kind of because the upside, I guess if you are able to in some sense inspire the research community to work on your data, it could be, of course, an upside, but again, the downside if you step wrong is so huge. So yes. Third question here from Antonio: is the strategy to move forward with specialized models fitted for purpose, or use foundational models such as GPT-3?
No, we don't use GPT-3, but those will be specialized models based on a specific use case.
Yeah.
For example, the first example we were using BERT, and then they were using another one from Facebook, and I don't remember that one. Probably it's the same one. So I mean, we tried a lot of different models, and then we switched between them. But I don't think we'll go for GPT-3.
No. Yeah, actually, I was playing around with Mikael Riegler from Simula yesterday with GPT-3, and it's extremely good. And when you talked about how to kind of understand pieces of the text, you showed one the text there where you had some kind of misunderstanding. It was really good at just extracting the important information and also to answer questions, actually. Of course, then you had some parameters to adjust whether you should give factual answers, or you could also give wrong answers. Of course, that's also. But you had some parameters like temperature and so on to kind of put some constraints on the code so that it only gave factual answers.
Can I elaborate on that point? So you're right. And when we evaluated GPT-3, not 3, but we evaluated GPT like 1 year ago. And the thing is that is very useful for a conversational agent. So like chatbots, they are conversational, and then you need to know a conversation, and the agent needs to know the history behind it as well. But for an email-based agent, you don't need that complicated model. Any kind of simple model will work. And most of the models right now, most of the NLP models are pretty sophisticated. So if you're building a chatbot, consider GPT. But if you're considering like an email agent or simple and NLP, any model can help you out.
But when you kind of have a response from the model, then an email response, is this you have both kind of a complaint or some input from the user, and then you will respond in an email? Do you also include the traffic data and so into the response, or how is this actually? How is the automatic response understanding what it should say in a sense?
That was step 2. That was step 2, making it more contextually aware.
Yeah.
I don't think it's contextually aware now, but that was like step 2, like giving it more data, connecting it to more systems, making it more intelligent. That would actually be more, I agree with you. That will be more useful.
Exactly. And just to follow up myself, there are several questions here, but you also said that students were working on this project, and they created a lot of value, as I understood from you. So how do you do that? Are those kind of typical master students, or are you into public PhDs, or how do you collaborate with students?
Yeah, so we have, so within the data science and AI department, we have a small team called the AI lab. And so what we do in the AI lab is we look for, first of all, we look for a project, a real business need which can be solved. And then we hire 4 students every year in that AI lab. Now those students can be either bachelor's, master's, or PhDs. We don't really care. The only requirement is that you need to be actively involved in any kind of education, as long as you have machine learning knowledge and some Python development experience. Most of the hires we have done, I think we received only 1 or 2 students which were masters. Most of them were bachelor students, and most of them were in their 2nd year or 3rd year. So we were amazed, like 2nd and 3rd year, they are really fresh, right? They don't have so much experience. They have just studied a few courses, and they amazed us.
A lot of excellent young talents in Norway, I think.
Mm-hmm.
But how do they do this practically? Do they do this on at the side of their studies, or do they work in periods during the summer, or how do they
So
actually do it?
Yeah, we hire them on a full-time basis from May, June, July, 3 months, 3 months during summertime. So that time they have to work full-time. And then we offer them a possibility for an extension of the contract for a 20% basis, so that they can do in addition to their studies as well. But those 3 months are supposed to be full-time inside the office with our team.
Exactly. And I don't know if you know, but NORA is also putting up a national research school in AI. And of course, we are always looking for more industry and public PhDs. So when you do, if you have any plans for more heavy projects and research, it's an excellent way to collaborate with the research community, I think. And we have a lot of, as you say, talent in Norway, both at the bachelor, master's, and PhD level, of course.
Absolutely.
I will go through some more questions. Hypothetically, if a claim issued by a user mentions data enough about, say, a trip where music was too loud and the driver was rude, giving the time, etc., do you have to anonymize the identifiable data related to the driver, or do you just anonymize the data related to the complaining user? And this was from Silvina.
I'll have you read this question one more time.
Yeah, I think maybe I read not too well there, but do you anonymize the user that kind of writes the complaint, or do you also anonymize the bus driver if it's a complaint directed towards the driver?
We only anonymize the user itself, but so it's important for us to identify where did the complaint happen, and we have different operators who are running different kind of services inside our areas. So what we also do is we collect those complaints for those operators, and we send it back to the operator so they can also look at the complaints and improve on them.
Exactly. And then another question from an anonymous attendee, and this is about trust and explainability. Not a question, but maybe using more explainable AI will help increase trust with the legal department in regards to the new AI methods.
Yeah, you're right. You're absolutely right. That will actually help a lot. Because most of the questions come from the legal oversight, GDPR compliance, data tilsyn and all that. So I think explainable AI will help a lot over there.
Do you use AI related to computer vision at Ruter?
Not right now, but we have been thinking about it in various aspects. One of the very good use cases was the cameras inside the bus. and there was we were thinking on how to capture the feed from that camera. But again, the problem is like it's a data privacy issue, because as soon as you can see the face of a user, that's a problem, and we're not allowed to access that feed. So we have been playing with some ideas, but we haven't really landed on anything yet.
We have actually some more questions in the chat also, I think. Yeah, one from Sachin. How good are the language models for Norwegian?
They were pretty good, actually. We experimented with BERT, we experimented with Spacey, and they have evolved a lot in the last few years, I would say. But the problem is not with the models itself. The problem is with labeled data which you can use to train those models. For example, the sentiment analysis which we did, the library which we used to train that model was all based on open source data, and we use a lot of curse word. We also use a lot of reviews from Yelp, and then we use that data and we train our model. So there are not enough open data sets available in Norwegian or Swedish language which we can use. And I mean, for us, in a specific scenario, Ruter itself, our use case is special. So if our customers are complaining to Ruter, they're using our language, our scenario. So like our sentiment analysis was also off by some specific %, right? So that's because we did not use label data inside Ruter. That's the step 2 we are planning to do, like have more label data available, so we can increase the performance of our models too. So to answer your question, the algorithms are fine. Algorithms are being enhanced every day. Data is not. Data is hard to get by.
Exactly. Yeah. And the following up question from Sachin here: how is it if you mix English and Norwegian? How is the algorithm dealing with that?
Right now, we're not using English at all.
No,
we're only using
Norwegian. Yeah.
We were like, yeah, but we did a test. It was fine.
Excellent. Yes, Sachin also asks whether you have any collaboration. We have several good groups, but he mentioned especially Lilja, Norbert. It's at the University of Oslo. If you have any collaboration with the universities.
The only collaboration we are in conversation with right now is Oslo Metropolitan University, and they are helping us out with the quantum AI part. But apart from that, we never had any collaboration. And yeah, we would like to have more collaborations, but we were just working on our own.
Yes, and yeah, one more question. I guess you have partially answered it, but what kind of transformers do you use? Do you build your own
transformers?
Yeah. What kind of algorithm, deep learning algorithm, or transformers algorithm? What kind of AI algorithm? You answered, I guess, Norbert or something, or Bert.
Well, to give you a high-level overview, like we are doing some capacity prediction algorithms. We are doing NLP on one side, not doing so much more on NLP, but like regression models. Yeah, these kind.
Exactly. And yet another question. Have you thought about using active learning in case it helps the situation you have with little relevant data?
We have actually, but we haven't really done anything around that yet.
Let's see. And you have a lot of thank you, great webinars and so on. We can send you the chat after the webinar here. A lot of thank you. I will just see if there are any more questions in the chat. Yeah, one actually that I found here up in the chat. Remember, if you have further questions, write them please in the Q&A. It's easier for me to keep track of them. But one more. So how is Ruter making use of AI to track customer complaints on issues of wrongly purchasing one-off tickets? For now, Ruter deems it void and no refund is made to the customer.
So any kind of complaints which are coming in goes to this customer insights thing. So this customer insights is a way to get for us to get an idea like what kind of issues are creating more noise. We have to look in it and we have to fix those issues. So that's another thing. But when it comes to following up on a case, that's like the traditional customer services department, and they are better equipped to answer this question than I am.
And I think now one last question or maybe comment is from Helsinki, where they propose to use the accelerometer data from phone to classify the kind of transport used. Have you been playing around with ideas like this, using kind of, for example, phone data from the customer then you could of course track acceleration, for example, in principle. I don't know if that's possible even or allowed.
Again, like that would be a huge. I don't know if it did this be a violation of customer privacy or not. If customers allow it, perhaps, but we have not really experimented with that idea at all. Ticketless travel. Okay, I saw that word.
Yeah, so the last one there.
Insane. Okay, interesting point.
Very interesting, Sachin. Yeah,
All
more
right.
is popping up. Helsinki public transport is going to use it.
Yeah.
Very interesting. I don't know if you have any more. Even more questions. A lot of questions to you. So you really have managed to interest the audience, I think. Do you use any AI to track your bus drivers?
No, we don't. Why would we do that?
A trick question for you. No, that's good. I think then we just will say thank you very much for a great webinar and a great talk and a lot of good questions from the audience and good answers from you, Umair. Thank you very much. And as you see from the chat here, a lot of people also says thank you and great talk. Thank you very much.
Thank you for having me.